Assalamu alaikum wa rahmatullahi wa barakatuh. Today we are going to explain the lesson of limits, and we are going to talk about a specific part of this lesson, which is finding limits using graphs, or we can say finding limits graphically. So to understand this, we need just first to go through the objectives of this lesson. So all what we need now to know is the difference between the exact value of a function and the intended value of a function. And you can see later that the exact value of a function, it means the exact height of a function at a point. If I have a point x equals a, what's the exact height on the function? And the limit, it is the intended height. So when I say the intended value of a function or the intended height, it means I'm talking about something called limit. So the limit is the intended height, while the exact height is the exact value of a function. Let's start first with the meaning of exact value or exact height. If I want to find, for example, the height of 1, it means if I want to find f of 1. So in this case, I take or I look at the graph. Where is the value of 1? What's the height when x equals 1? So clearly f of 1 is 1 itself. If I take, for example, 3, so what's f of 3? f of 3 here, what's the exact height of 3? So in this case, I go and search what is the exact height of 3. It is a little bit less than 2. So f of 3 is less than 2. If I take 4, so the exact height of 4 here, so f of 4 is exactly what? 2. So f of 4 exactly 2. So that means the exact height is just to look at the graph and see what is the location or what's the intersection between this line and the graph. So what's the height of 4? What's the height of 3? What's the height of 2? So this is called the exact value of a function, or we call it f of a. So this is f of a represents the exact. But now let us talk about intended value of a function or intended heights. If I want to find what's the intended height when x goes to a, when x approaches a, from the right or from the left. Of course, I can go to a from the right or I can go to a from the left. So what are the intended heights? As you can see here, the first height here, for example, if I start from this point, if I start from that point, also this is the first height. So these heights are moving or are changing, then they are approaching this height, which is g. So the limit or the intended heights are moving towards g from the right. Also from the left, as we can see, the heights are increasing, and at the end, before they reach a, they are moving towards g. That means the intended height when x goes to a is g, which means the limit when x goes to a equals g. Or we can say the limit when x becomes closer and closer and closer to a from both sides, the heights are going to g. So this is the meaning of limits. Also another example to understand the limit. When I go to 1 from the right, the graph is going to this point, which is 2. And when I go from the left, also it is 2. Although the exact is not defined or is undefined, but the limit exists, which is almost 2 or it is 2.
Let us solve some examples to understand the difference between the exact value of a function and the intended value of a function or the limit of a function. Let me start with the first graph on the right. Let me find first f of 2. If I want to find f of 2 here, so I need to know what's the value of y when x equals 2. What's the value of y when x equals 2? When x equals 2. Since I don't have a function to replace, so I go to the graph. So I stand on 2. Then I move up vertically or draw a line to see where this line where does this line meet the graph. As you can see here, there is a hole. That means there is no intersection point. That means there is no value of y when x equals 2. It means f of 2 is undefined. So when we want to find the exact value of a function, we stand on the point and we see where is the point or where is the graph at that point. So here the f of 2 is undefined. Now if I want to, for example, I want to study the second graph here. I want to find f of 2 here. F of 2 here, which is the exact, also I do the same. I stand on 2. Then when I go up, I will meet the graph at 4. That means f of 2 defined and equals what? 4. But the first graph, the f of 2 is undefined. Now what about the limit? So let me start the limit or study the limit. The limit, we don't say stand, we say we go. When I go to 2 from any point, so I can go to 2 either from right, means from 4 till 2, or I go to 2 from left, or I go to 2 from left. When I go to 2 from left, it means I'll start, for example, from 0, from -1. It's better to start from a number close to 2. So I go from 0 to 2. Now I want to see where is y? What's the intended value of y? Which means I need to first start from 4. 4, the height is 6. That means the position for 4 is 6. But I need to move like this to 2. So the graph also will be moving towards this point. Or I can say the heights here are changing and they are reaching what? The point 4. That means the limit equals 4 from the right. I can imagine this one by saying I have a car here and I move my car from this point till reaching the destination of 2. So I reach this height 4. That means the limit equals 4. Okay, if I go to 2 from the left, I will start from any point, let's say -1 or 0 or whatever. That means my car is here. Then I move towards, because till I reach the same point. So that means also y goes to 4. Which means the intended height. So the first height is 1. The second height is 1 point something, then 1 point something, then 2. That means the heights are going to also 4, or the graph is moving towards 4. Now, the left limit is 4, and the right limit is also 4. That means the limit in general, when x goes to 2, whatever the direction, left or right, when the limit equals 4. And for this graph, the same idea. The limit, of course, from both sides is 4, because it is similar to the exact. the limit equals 4. Now the graph in the middle has different ideas for all parts. So I will study first the exact, then we will study the limit. So if I take this graph here, I look at exact. So the exact of 2 here, as I said, we stand on 2. Then we go up. Here I will meet 2 circles. The open one, it means there is no graph here. But the shaded one, it means there is graph here. That means the exact height of 2 is the shaded circle, not the open circle. That means f of 2 is 5. Okay, now let's start studying the limit for this graph. It means I have to go to 2 from the right, and I go to 2 from the left. When I go to 2 from the right, I can see here the graph, whatever I start, the graph is moving till the final destination is this point, because we cannot jump. That means the values of y are starting from 7 to 6 till reaching 5. That means the limit from the right is 5. While when I go to 2 from the left, it means I will move from somewhere like -1 till 2. -1 has this starting point. Then I will move, so the final destination will be 4. That means y equals 4, which means we have 2 different limits. The limit from the right is 5, while the limit from the left is 4. Since we have 2 different limits, that means the general limit does not exist, because we have 2 different values. So that means if the limit from the left doesn't equal the limit from the right, the general limit does not exist at that point. Thank you.
So we will use this notation to express limits. We write LIM, it means the intended height. We write x goes to a, or x arrow a. It means when x approaches, or when x approaches a, or when x becomes closer and closer to a. Now L is the value of limit, which means here where the intended heights go. The intended heights go to L, so the limit equals L. So this is the definition or the limit. Now let us take some examples to know how to deal with limits graphically. Look at this example. Evaluate each of the following. Limit when x goes to 1. This minus means from the left. So what I do, this is 1, x equals 1. I need to go to 1 from the left. So what will happen to the heights? If I start with the first height, this is the height, the first one. Then when I move here, this is the second height. Then it becomes 0. Then the height becomes a little bit small, half or like that. Then so look at the heights are moving towards this point. That means from the left, the limit equals 1. Now let me start limits from the right. So also I start from any point like 3 or 4 or 5, it doesn't matter, but it's better to start from number close to 1. Let me start from 2 point something. So the height is 2. Also at 2 the height is 2. So there is no change in the height. That means all heights are 2. So here I got 2 different limits. The left limit is 1 and the right limit is 2. And we just said if the left limit at the same point doesn't equal the right limit, so that means the limit in general at 1 does not exist. We say does not exist, or DNE. Now what's the exact value of 1 or f of 1? When I say f of 1, I mean only the exact. As we said, the exact is the shaded point, and the shaded point here is 2. So the shaded point is 2. This is just an example to understand the limit. Let's take another example also here. The limit from the left when x goes to 1, so also we go to 1 from the left. So in this case, we know the heights are like these. So the heights are going to -1. So that means the limit from the left is -1, while from the right, when I go, the heights are going like that till reaching 1. So the limit from the right is 1. And since they are different from each other, they are not equal, so the limit does not exist. And also here, the good thing is to know what's the exact value of 1. Here, the exact value of 1 is not this. It's not exact. And it's not this. It's also not exact because it's not shaded. So the shaded only that point. So this is the f of 1. So f of 1 here it's 0. Now let us talk about this example when x goes to a number, but the graph is going for no value, or going up forever or down forever. We can see here when x goes to a from the left, the heights are changing, but the heights 2, 3, 4, 5, but then the heights are going forever for plus infinity. So in this case, we can say the limit from the right is a plus infinity. And also, when x goes to a from the left here, also the heights are changing till reaching -infinity. So in this case, we have two different limits. One, x goes to infinity, one, x goes to -infinity. So also the limit does not exist. More example also here. The limit from the left, as usual, clearly is going to 1. And from the right also is going, the heights are going to 1. Since they are equal, so the limit in general is 1. Now what about f of 1? Also we said the shaded point, so the shaded point is here. So the shaded point here is -2. Let us take this example also here. This is a little bit good question. Limit from left when x goes to 2 from left. So we can see here the graph is, or the heights are increasing till reaching infinity. So they are going forever or upward forever, which means we can say plus infinity. So from the right, it is a plus infinity. While from the left, when I go to x from the left, the heights, look here, half, then 1, sorry, -1, then -1.5, then -2, then -3, till going forever down. So it is minus infinity, which means the height from the left, sorry, the height from the right is -infinity. And since they are not equal, so the limit does not exist. The limit does not exist. While f of 2 also here, there is no shaded point, so we can say unknown or undefined. One more example also here. Limit from the left when x goes to 2, also the heights are going to plus infinity. And from the way, by the way, we can write only infinity or plus infinity, but it's better to write plus infinity. From the right also, the graphs are going up, so also plus infinity. Since they are equal, both plus infinity, so the limit when x goes to -2 also plus infinity. While the f of -2, there is no shaded point, so it's undefined. Now we have reached a conclusion to see within one graph all cases of limits. Look here, when we have only a hole, the limit exists. When we have jump, the limit does not exist because we have two different limits. When we have one goes to infinity, one goes to -infinity, also the limit does not exist. When you have no cut, no jump, no hole, the limit exists. When you have only hole, the limit also exists. When we have jump, the limit does not exist, and when both goes to different directions, so we say the limit does not exist. Let us take this example that has many questions. If you look at here, the limit when x goes to 4, you can see this is 4 here. So from the left or from the right, there is no cut, no jump, no hole, so the limit exists and equals 2. When I study limit x goes to -3, this is -3. Also, left and right, they have the same heights, and because there is only a hole, so the limit exists and equals 2 point something, which is, or exactly 3, sorry, exactly 3. When x goes to 0, also here, I go to 0 from the left and from the right, and both are going forever up, so the limit equals infinity, or sometimes we say plus infinity. When x goes to -6 here, -6 here, only from one side, there is no other side, we have no idea about other side, we say the limit exists and equals to 3 only, but from one side, so we can say the limit equals 3 from one side, which is the right side. Limit when x goes to 2, also here we can see clearly that there is jump here. It means we have two different heights, which means when I go to 2, sorry, from the left, the height is 2. So I have first height is 2, while the other height, when I go to 2 from the left, I have different height, which is 3. So we have two different heights. In this case, we say the limit does not exist. The limit does not exist. Okay. Also at 5, here there's only a hole, so they have the same height, so the limit exists and equals 2. This example is good because it's revision for all cases. Now, I will keep for yourself and the conclusion for all these. The word limit means the intended height, and the limit exists only if the left and the right are equal. The left hand and the right hand limits are equal. A limit can exist if there is only a hole in the graph. A limit will not exist if there is a break or a jump in the graph. To test yourself these questions to be solved later by yourself, to know the difference between the limit and the exact.